All right, so let's see if we can figure this out. How are we going to maximize the probability of correctly rejecting HO? That would be this area here, 1 minus beta. How do we make this area as large as possible while minimizing these two areas, which is where we can make a mistake? All right, now there is one very simple solution to this, and that is all you have to do is change your critical value. So we can move this critical value either to the right. In other words, if we move it to the right, we're making it larger. It's a bigger number. Or we can take this critical value and we can just simply slide it to the left and make this a smaller number. All right. So let's look at where it is right now, and we see that alpha is a pretty small area, so the risk of making a type 1 error is pretty small. Beta, however, is fairly large. That's the probability of making a type 2 error. And then here is the 1 minus beta area, the probability of correctly rejecting HO. Now that's if we choose this as our critical value. It's the critical value that starts this 0.05 rejection zone, okay? Now, what if we wanted to make beta smaller, right? So wouldn't we just have to slide this number to the left, right? That could happen. Or what if we wanted to make alpha even smaller? Right now it's set at 0.05. What if we want to make it 0.01? So that's where you look down here. If we want to make alpha 0.01, well then clearly we need to use a larger critical value, right? So here's where it was initially. We are sliding it to the right, so this becomes the new critical value, and we have effectively minimized the probability of making a type 1 error. So alpha got really small, it went down to 0.01. Now, you might think that's great, wonderful, but what about the other areas under the curve? Well, look what happened to beta, right? Didn't beta get a lot larger? Because compare it here and versus here, we can see that beta actually got larger. And what happens if beta gets bigger? Well, 1 minus beta gets smaller. So if you compare the two 1 minus beta areas, we can see this is a smaller area. And this is bad, right? Because we want 1 minus beta to be as large as possible. So again, what can you do? Well, you can slide the critical value back. All right, so that would be up here. We take the critical value, we slide it to the left, making it a smaller number. And what have we done? Well, we have made beta smaller compared to here, right? So beta got smaller. 1 minus beta, this area got larger compared to here. So you're thinking, this is great. We've made this smaller, we've made this bigger, but what have we done to alpha? We've made alpha a lot larger, right? So here it was 0.01 and now it's back up to 0.05. So just moving your critical value to the right or to the left, you can change the areas under the curve, but there's always going to be some sort of compromise, right? So in other words, this is not an effective solution because you might gain in one area, but you lose in another area. So the question becomes, is there something else we can do to minimize error and maximize the probability of a correctly rejecting HO? In other words, maximize power. And the answer is yes. All you have to do is increase your effect size. And this will give you a win-win-win situation. In other words, it will minimize the probability of both errors simultaneously, as well as increase the probability of correctly rejecting HO. In other words, maximize power. All right. Now, I know you're wondering, what is effect size? Stay tuned.